Okay. So this unit is all about integration, and this is like where it's a skills-based unit. You are going to get so much practice time. You are going to be assessed so often. For those of you that don't do the homework on a regular basis, you know what? You're going to be assessed in class so much. This might be the time where you start to realize, wow, I really need to start doing my homework because I seem to be doing an assessment in class every second day. I mean, let's just see what happens with that. But one of the key pieces to really doing well in this unit is understanding all those derivative rules from forever ago. And if anybody would like, I have a copy of all the derivative rules that you need to know that Henry is going to pass out. Thank you, Henry. You didn't realize what you were raising your hand for. Too bad. No. All right. So there's that. I'm going to take attendance in just a bit so I can keep this fabulous job. You all are going to have a quick conversation at your desks, tables, groups, whatever. Okay, and for Gerardo, for Sylvia, for Rebecca, and somebody else, and Andy, who was out yesterday, you're going to want to just listen more than you talk during this time. But the conversations over the next minute or so are, what's the difference between these two? I want to hear the vocabulary terms. I want to also hear the question. What's the question that's being asked over here compared to what's the question that's being asked over here? It is going to be a sea of noise because 28 people are going to be having, 24 people because the 4 absent people are going to be listening. You got a minute? Go for it. Thanks, Henry. And Henry, glasses look good. 4, 8, 10, 13, 17, 18, 24, 28, full house. Love it. Didn't love the show. Didn't love having a full house. Use your notes from yesterday if you need to.
You have a pencil.
I found it in my bag.
Focus is all there are lots of heavy things back here. More talking, more talking. Why one? Alrighty, Daisy. Daisy, what's the difference between these two?
So the one that has the definite, the first one is a definite integral.
The first one is a definite integral. Everybody's okay with that?
Yes.
And the second one is called?
An indefinite.
Everybody, what's it called? An indefinite integral. A definite integral versus an indefinite integral. Michelle, what's the question being asked over here?
How much area is like bounded by the x-axis?
By the x-axis.
The function.
A function.
And then from f of x equals a to x equals b.
Okay, this one asks the question, how much area is bounded by the function in the x-axis from x equals a to x equals b? I know I keep asking this question because it is a fundamental question. Rubio, what's the question being asked over here?
Yeah, what family function has f of x as its derivative?
What function or what family of functions has this guy as its derivative? So that derivative is a really big piece here. But the thing is now, your integrand, little f of x, is the derivative answer to the question, what function has this guy as its derivative? This is how we start to, we're going to have to learn to dance backwards in this process. And some of you yesterday, like smarticle particles were already firing off. Michelle was like, I was one of them. No, it was a good day, good day. So I've got, 13 integration formulas that you're going to want to start memorizing. But I'm curious how many of these you already just know. I want you to take 2 minutes and look it over this list. Which ones do you already know for a fact? If you know it, write it down. Don't use pen because maybe you're lying to yourself, Paul. 10 is bad.
N plus 1 x.
90 seconds.
Don't forget C, guys.
Thank you, Diego. Don't forget about Charlie.
That's what I did.
Don't forget about Charlie. Thank you, Miss Blakey, for that one. That's a lot of credit. I wonder if I get credit in her class.
Charlie was the name of the dog.
1 minute left.
Charlie got run over.
Garrison's got 1, 2, 3, 4, 5, 6, and he thinks he knows. Oh, he knows he knows.
Basically, just like you know, it's basically where Charlie's
I didn't write it down. So C is like the barrel at the end. You know, like it's an equation.
Becca's got some, Jeanette's got some, Paul's writing all over the place.
Ooh, look at that. Around there.
Number 2 is elevator.
Alright, friends, I want to get some hands on this. Give me any of these that you know for sure. I got stuff in my pockets. It might even be edible. Who knows? Diego, give me one.
Number 3 is the square root of x plus c.
Okay, the antiderivative of 1 over 2 square roots of x is the square root of x plus c. Nicely done. Why is that? Because we have known for a long time, derivative of the square root of x is 1 over 2 square roots of x. Jose.
Number 6.
Number 6.
The sine of x plus c.
Sine of x plus c. Love it. In fact, so moving forward with your answers, don't just say the number, I want you to read it. So like Jose would have said, the indefinite integral of cosine of x with respect to x is sine of x plus c. Jackie. Wait, which number though?
10.
10. Ooh.
Of 1 over x squared plus 1 with respect to x is on tangent of x plus c.
Indeed it is, dear. Indeed it is. Well done. The indefinite integral of 1 over x squared plus 1 is arctangent of x plus c because derivative of arctan of x is 1 over x squared plus 1. What other ones? Sheila.
For number 2, the indefinite integral of 1 over x with respect to x is natural log of x plus c.
You are good. However, there is a small problem, and I talked about this yesterday at the very end of class. Sylvia apparently watched that part of the video. Sylvia, what do you know?
You need the absolute value sign.
You need the absolute value bars there. Anybody know why? Yeah, that's what I thought. Okay. Here's why. The graph of the natural log of x function looks like this, which means it's only defined for values of x greater than 0. However, the graph of the natural log of the absolute value of x looks like both pieces, so now you have x is less than 0 and x is greater than 0. Because you don't know is x positive or negative here, you're going to go with natural log of the absolute value of x. Those absolute value bars are essential pieces. And I'm just going to beat this into you, not physically beat. Why? Well, maybe. Okay. Other ones. Other ones. Paul.
Number 5.
Number 5.
The indefinite integral of sine of x with respect to x is negative cosine of x plus c.
The indefinite integral of sine of x with respect to x is negative cosine of x plus c. Good. Others. Others. Destiny.
Okay, number 8.
Number 8. How would you read it? And then what is it?
The indefinite integral of e to the negative x with respect to x is negative e to the power of negative x plus c.
The indefinite integral of e to the negative x is negative e to the negative x plus c. Indeed it is. Others. Garrison, get in there.
Number 7.
Number 7. Read it and then tell. Oh, Garrison.
The indefinite integral of e to the x with respect to x
is e to the x plus c.
The indefinite integral of e to the x with respect to x is e to the x plus c. I don't think... Oh, I can't break it. Sorry. I was trying to break it. Henry.
Number 1.
No. Go for it.
The indefinite integral of x to the power of n
Yep.
with respect to x is 1 over n x to the power of n plus 1.
I like it. I don't love it. Like it. Don't love it.
Oh, plus c.
Plus c. Still like it. Don't love it. Still don't love it. What's the antiderivative of x to the fourth?
4
X to the fourth.
1 over
4.
What do you take the derivative of to get x to the fourth? Not 4x cubed. The derivative of x to the fourth is 4x cubed. The question is, what do you take the derivative of to get here? 1/5 x to the fifth. The exponent gets bigger by 1.
Yeah.
Henry, can you fix it?
N 1 over n plus 1.
It's 1 over n plus 1. Because what happens in the derivative process, you bring the power down and you multiply. So the n plus 1 and the 1 over n plus 1 are going to cancel each other out or multiply to give you 1. Okay, good. I apparently ran out of lifesavers. Ooh, have some. I think they're fresh. We'll find out. Okay, so we've still got others that we're staying away from. Diego,
Number 4.
number 4. Can you read it and then tell me what it is?
The indefinite integral of -1 over x squared with respect to x is 1 over x plus c.
1 over x plus c. Gonzalo, are you stealing life? Okay, number 9. Any takers? What would you take the derivative of to get 1 over x plus b, where b is a constant? It's the natural log of the absolute value of x plus b. Think about what happens when you take the derivative. The derivative is 1 over the stuff times the derivative of the stuff, but the derivative of the stuff is 1. Okay, ow! You know what's also in my pocket? A push pin! Why couldn't you have taken that, Gonzalo? All right. Oh, you did! You took, no, that's, I only hit you with paper. All right, number 11. K is a constant like 2 or 3 or 5. What would the integral of e to the kx be? Think about what happens when you take a derivative. Floor, get in there.
Would it be the indefinite integral of e to the power of kx with respect to x equals e to the kx plus k plus c?
Not e to the kx plus k plus c. I'll tell you, e to the kx is definitely part of the answer, so is the c. Think about what happens when you take the derivative. What happens when you take the derivative? Marilyn? When you take the derivative is e to the kx times k. There's no times k here. So what you would need to have is 1 over k. Because think about your derivative. K is a constant. The derivative of 1 over k times e to the kx is 1 over k times e to the kx times the derivative up here, which is k. And the 1 over k and the k, we're going to cancel each other out. Which then means, I think we know what happens with the next one. Antiderivative of sine of kx is negative cosine. The angle always stays the same. There's a plus c, and there's 1 over k. Because of the chain rule when you take the derivative. Okay, k is a constant. The antiderivative, or the indefinite integral of cosine of kx is? Sine for sure. Sine of kx plus c. And then 1 over k again. 1 over k again. Those are the 13 that everyone needs to just get memorized. I would recommend flashcards. I'm going to do a foldable someday next week so we can get together and make the foldable. Sheila's going to be there, I can tell. And then for those of you that are really hungry for a 5, here's 4 others that are going to show up. So if you're like making flashcards, I would put these other 4 on the flashcards as well. What I want to do is give you guys the next 2 minutes, but only 2 minutes, to quiz one another, have some conversations. The conversations are going to sound something like dude, what's the indefinite integral of cosine of x? You're gonna be like, bro, it's sine of x plus c.
Yeah, dude.
And then dude and bro are gonna switch places. Okay, 2 minutes, go for it.
Indefinite integral of cosine
Hey, yo, what is the cosine? The 1 over k.
Well, no, the difference here is that your variable is in the base. You're saying
Never mind. You're right. Wait, the derivative is cosine of the sine. Negative 1 over x.
It's like a
Plus
circle.
c.
So on these, right?
So the reason you multiply by 1 over k is if you were to take k is a constant, so you would ignore the cosine part. The derivative of cosine of stuff is negative sine of stuff. Oh no! Times the derivative of stuff. Okay? So the negative, the 1 over k, and the k that you're multiplying by, multiply by the simple half rate.
It's the Eiffel Tower. It's the Leaning Tower. Somewhere in
You're broke. You're both. I have more questions in my pocket. Stab myself in a bad place. Oh my god, this is the quietest group ever. No one is rude or dude or bro. Help each other out. Take your head out though if necessary. All right, dudes and bros, we're gonna put your money where your mouth is. Okay. So, I want to give you guys practice time. One of the other things I like about this unit is you're going to get a lot of practice time. Sometimes on your own, sometimes with a partner. You've got the next 3 minutes to find the indefinite integrals for all 4 of these with no help from anybody. It is going to be a silent time. Oh, my favorite time of the day. When you're done with all 4, when you think you've got it, call me on over. And if you've got all 4, you get a sticker. If not, I'll say, you're close, keep going. But 3 minutes from now, we're all going to come together and make sure that we're good. Okay. 3 minutes of silence. Starting right now. They have to be perfect to get my sticker. You can't be done, okay? No. Hold on, I gotta get my stickers. Yep.
Ready to move.
You find it, we call it sometimes the antiderivative because you're reversing the derivative process. Gotta get all 3 right. I mean, all 4 right. Jackie, thank you for being there for me. Be careful, cuidado. Push pins. Push pins. Stab yourself and push pins. Everything has to be beautiful. That's the only problem. I haven't seen any perfect papers yet.
Off trade.
Ah, good job. What color? Green. Okay. Still working on your own. Blah, 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 blah. There you go. What color? Blue. Here you go. All right. Here we go. First one, x to the fourth minus x squared plus 7x plus Charlie. Even if you didn't call me over, I checked most people had this one. Okay. Antiderivative of t to the 11th. That's that power rule where you're like, oh, 1/12 t to the 12th minus 1/9 t to the 9th minus a half t squared. And here's where people start falling apart. What do you take the derivative of to get square root of 7?
Okay.
I want to come back over here. What did we take the derivative of to get 7? 7x. 7 is a constant, right? What do we take the derivative of to get square root of 7?
Square root of 7,
T.
T. Square root of 7 times t plus Charlie. So like this is a place I would circle, I would draw some attention to this, I'm going to be way picky. And then I saw most people had this. Antiderivative of sine of x plus cosine is negative cosine of x plus sine of x plus c. This guy over here is e to the x minus e to the negative x plus c. I'm curious, how many guys got 3 out of 4? And how many of you, the one that you didn't get, it was number 2? It was that square root of 7 times t?
Yeah.
Yep, I saw a lot of folks who said just square root of 7 or square root of 7 times x or 1/2 square roots of 7. This is still a constant, so be careful. All right, with that said, you get another 3 minutes.
Wait.
Hold on a second. Okay, there are 6 more problems. I'm looking at 5 through 10. You've got 3 minutes. You're working in a group this time. Do the best that you can, and I'll put my answers up there. 3 minutes, I'm coming around to Sylvia. If you haven't taken the cups out, please take the cups out. And your... Ooh. Whoever's the angriest one in the group, you're in control. That's Rebecca in her group today. Yes, dear. I'm putting the and if you want to, I'm putting the parentheses here to say I'm finding the integral of everything that comes out. Everything between the integral and the dx. I'll wait. Watch those variables. I'm picky.
It'll be square root of z.
Absolute
Definitely not square root of z. No, that's not a thing. Although I guess you could, it would be the 4th root of z, but you've got all those formulas. Use them. So one of the things in the video is that when it comes to
Look at 4 from the
constrained growth, it makes that shape. So you've got like your limiting capacity. The fastest growth always happens when you're halfway. So as soon as you recognize the carrying capacity at the halfway point, that's when you are growing the fastest. The tricky part though is like if you talk about we say it's like squirrels. Right? 1,000 squirrels is the carrying capacity. When the squirrel population is growing fastest is when the squirrels. All right, bye. I'm not telling you when.
Sine of X, right?
You're saying when the population is at the halfway point. At that point, that number of squirrels is when the population goes down. But it doesn't tell you the time. Good, good. Nice, good, keep going. Okay, you're in a good place if for number 5 you've got square root of z plus natural log, absolute value of z plus Charlie. Over here, natural log of x plus 1 over x plus Charlie. How many guys honestly had both of those? Part of what we're just going to have to do is get practice memorizing those integration formulas. You just got to know them. Brood? Yeah. I'm generally not going to write it that way. Hi. Why would it be plus if it says minus? Okay, you're asking me about over here? Okay. What's the derivative of 1 over x? The derivative of 1 over x is negative 1 over x squared. Okay, you guys have 1 more minute. Just get as far as you can. I don't expect anybody's going to get all of them. Yeah.
Wait, is it just like that negative 1 over 2?
I like it.
Where are you putting 2?
It's
Oh, you can just bring it down. You can just bring it down a little bit.
I'm talking about this one. The second one is like 1/2 times. Wait. Is it
Perfect. Yep.
You can get negative cos of x squared. And then you can bring down the x. Or you can bring down the 3.
So, try it.
No.
Right? If you're like 1/2 cosine,
Wouldn't the
what happens when you take the
derivative
derivative?
of cos of x be, what's it called?
This is negative.
Yeah. Alright, so if you would have had that squared, wouldn't you still bring the 2 down?
Alright. Alright. Now, here's the thing. I don't think anyone realistically got through all of these. Not even a little bit. And I only want to talk about 7, 8, and 9. And your skills are going to get really good. So, a couple of things here. How many of you guys were thrown off by having that 6 there? Like that caused some problems? What if it had just been 1 over t? ln of the absolute value of t. Well, 6 over t is just 6 times 1 over t. So the antiderivative is 6 times the natural log of the absolute value of t. And so I bet if you're getting thrown off over here with the 6, the pi was even worse. What if this was just 1? What's the antiderivative of negative 1 over t squared?
1 over x.
Wait, which one?
1 over t.
1 over t, not negative, but positive. It would be 1 over t. But that pi is in the numerator, so you're saying it's pi times as much. So the antiderivative is pi times as much, it's pi over t. And then plus Charlie. How many guys honestly get that one right on your own? Nice, you're in a good place. For everybody else, don't worry, we're going to get there. Okay, this next one, antiderivative of 2 sine of x. Let's do it the same way. What's the antiderivative of sine of x? Wait, one more time? I thought I heard somebody say cosine, but maybe I was just crazy. The antiderivative of sine is negative cos. This is 2 times sine of x. So this would have to be negative 2 times cos of x. Okay? Plus the antiderivative of sine of 2x. Well, that's just like one of those first problems, except now k is 2. So go to your notes. What's the antiderivative of sine kx?
1/2.
Negative 1/2
But who came out?
times 2x.
Right, it's going to be negative 1 over whatever your k value is, 2, times the cosine of 2x. right? Because you're saying sine of 2 times x, so the antiderivative is negative a half cosine 2x. And if you're not sure, check the derivative. The derivative would say negative a half times derivative of cosine, well that's negative sine of 2x, times the derivative of the inside, which is 2. Kind of okay? We're going to get better. All right, antiderivative of e to the 3x. Oh, that's just like e to the kx if k was 3. And that's going to have to be 1/3 e to the 3x. Antiderivative of e to the negative 3x, well that's just like if k is negative 3. So plus 1/-3 e to the negative 3x plus c, or if you want, minus 1/3. I'm not interested in number 10, not even a little bit. Everyone kind of feeling okay? All right, here comes the push. You're like, no, I already had it. Nope, you haven't had it. You're about to get it.
Gonzalo, hide your head.
It's gonna be okay. It's gonna be okay. Because here's the issue, friends. Here's the issue. All the problems that we've looked at so far just require you to have memorized some things. And any one of you can memorize some formulas, some rules, and be okay. This next set of problems is going to be a push because none of these things show up in your list of formulas. You're going to have to get creative. You're going to have to do some algebra trickery. Tonight's homework, and I think I may have forgotten to mention it, is assignment 88 to do all the problems. Some of them are going to be like the ones that we just did, and you're going to be fine. Others are going to be like the ones that we're about to do, and you're going to freak out a little bit. The good news is there are hints for just about every single question, because we're babes in the woods here. So I want to look at this first one. The indefinite integral of 1/square root of x plus the cubed root of x. Take a quick scan of those formulas that you're in the process of memorizing. Do any of these show up there? Take a look. Take a scan.
Yes.
Any of them? Really? Which one? I don't think I see either of these in the list of ones that you're gonna memorize. However, there are some things that you can do. Henry, I'm going to take it from here, okay? What I'm going to do is this. I'm going to rewrite the indefinite integral, and I care about notation here, Paul, so be careful. 1/square root of x is the same as 1/x to the half. Cubed root of x is the same as x to the 1/3. My first question is that legal?
Yes.
All right, that's just rewriting. How about this next move? Would this be considered legal? X to the negative a half plus x to the 1/3. We're still in the land of legal?
Yes.
So this is okay. Why would I go and do this? The reason I'm going to do this, Jackie, why do you think we're going to do this?
Because to be able to do it a lot easier.
Sure, there's that, but x to the negative a half, it doesn't really show up in your list of formulas. Look at the list of ones that you're memorizing here, or you're in the process of memorizing. It's not there exactly, but what do you see?
Could you just like an even denominator?
I'm going to come back to that in a little bit. Paul, what do you see? It's the power rule. The power rule says it's that very first one, that if I have x raised to a power, I add 1 to the power and I divide by the new power. So this is power rule if n is negative a half. This guy is power rule if n is equal to 1/3. It's that very first integration formula. It's that very, very first one. Well, the integration formula says, well, the antiderivative of x to the negative a half, I'm supposed to add 1 to the power, and then I'm supposed to divide by the new power. The antiderivative of x to the 1/3, add 1 to the power, divide by the new power. And that might look like the ugliest thing you have ever written. There's fractions all over the place. So let me say it one more time. I've got x to a power plus x to a power. The power rule says add 1 to the power, divide by the new power. So I said, okay, well my power right now is -1/2. Let me add 1 to that power, and then I have to divide by the new power. For x to the 1/3, add 1 to the power, divide by the new power. The fraction stuff is going to be a little ugly, but we can handle this. Because everybody knows that -1/2 plus 1 is
1/2.
1/2. So I've got x to the half. -1/2 plus 1 is 1/2. 1 divided by 1/2?
2.
2. So we've got 2x to the half. Plus, I think everyone knows this one too, 1/3 plus 1?
4/3.
So funny watching your eyes, you're like, 1/3 plus 1 is 4/3. So you've got x to the 4/3. Now I take 1 divided by 4/3, little keep it, change it, flip it, you get 3/4. Your antiderivative is 2x to the 1/2 plus 3/4 x to the 4/3 plus Charlie. That is the 100% absolutely all the points kind of answer. That would be good, I'd be done, I'd be happy. However, I'm also going to find ways to hide this from you. Garrison, what do you see?
2 square root of x.
Okay, so you're going to rewrite x to the 1/2 is square root of x, and that's a legal thing? And you know I'm going to do that too. What about over here? Have a quick conversation with somebody near you. How do I rewrite that? It's been a while. X to the 4/3, how does that work? X to the 4/3, I heard it from a lot of different folks. It's the cube root, the 3's on the outside of x to the 4th plus c. That's that multiple choice answer. That's how I'm going to hide it from you on the AP exam. All right. I think we're doing okay. We're moving in a good direction. We're going to get a lot of practice time in class, so nobody needs to freak out on me. All right, let's look at this next one. Antiderivative of x squared plus 4x divided by x squared. That shows up nowhere in this list. You are not going to memorize your way through this unit. You are going to start to develop some algebraic tricks. Because you're going to start to discover that division and multiplication are always bad news. So I'm going to look for a way to rewrite this in a way that's a little friendlier. A little friendlier way to rewrite this. X squared plus 4x divided by x squared. There's another thing you can do. There's a way you can rewrite this. I see Karina. I see Jackie. Karina, what are your thoughts here?
X squared divided by x squared plus 4x divided by x squared.
Okay. First of all, is it legal?
Yes.
It's legal, right? Here we're just saying, well, this is one fraction over one denominator. Why don't I just rewrite it as 2 different ones? Why is this helpful? What can you do now that maybe you didn't see before? Gonzalo, what do you see?
You can cross out you can just leave it as 4x over x squared.
You could just leave it as 4x over x squared, or you could do something. X squared over x squared, you guys all know is 1. Plus, Gonzalo, you started over here and you said leave 4x over x squared. That's okay, but there's also something else to do here. You could cancel out the x and one of the x's down here to get 4 over x. And this now is a problem that I think every single one of you should be able to finish it off from here. What function has 1 plus 4 over x as its derivative? Diego, sorry for spitting all at you. I totally spit all at Diego and I didn't mean to. So what has 1 as its derivative? What has 4 over x as a derivative? What has 1 as its derivative?
x.
1x or just x?
Yeah.
What has 4 over x as its derivative?
4 times ln of absolute
4
value of x.
natural log absolute value of x and then plus Charlie. The issue though is this like initial like, I think it's this part over here where you probably wouldn't have seen it. Once we make that move, it becomes a little more obvious. A little bit more. Okay.
Are you gonna do that?
Oh my gosh, yes. Multiplication is bad news in the integrand. Division is bad news in the integrand. See what you can do at number 3. E to the x plus e to the negative x, the whole thing getting squared. What? What? Daddy say what? If only there was some way to rewrite e to the x plus e to the negative x squared without using multiplication. If only there was something. Something from like algebra 2. I had a box to organize my thoughts.
The box method, that's what it's getting.
You have to work for it real hard sometimes.
This is the box method, that's what he's saying. Isn't that multiplication?
So I have heard from some really gifted people in the room that when you square something, it is the same thing as multiplying the e to the x plus e to the negative x with itself.
Yes.
I mean, I heard it from at least one guy in a nice green sweater. And then if I multiply it out, yeah, that was me. E to the x plus e to the negative x times e to the x plus e to the negative x. Now here's where we want to be careful and not embarrass ourselves.
Oh my lord.
E to the x times e to the x. Don't say it. Don't say it. Don't say it. Somebody out there is thinking it's e to the x squared. Somebody else is about to tell me it's 2e to the x. Those would be embarrassing things to come out of your mouth right now because the bases are the same. And when the bases are the same, the rule is, with the exponents, you add the exponents. Flora, thank you so much for saving us from the embarrassing moment here. E to the x times e to the x is? Oh, thank God. Okay, e to the 2x. Next box, e to the x times e to the negative x. The bases. Oh, what did you just say? When the bases are the same, you add the exponents together, and if you add the exponents together, you get e to the 0, which is 1. What about this box down here? E to the negative x times e to the negative e to the x is e to the 0 again, and I get 1. And that last box, e to the negative x times e to the negative x. Oh, thank God. Okay. The box isn't the answer. The box just organizes your thoughts now. So now we've got e to the 2x, check, plus 1 plus 1. That's 2, plus e to the negative 2x. And I still need to find the antiderivative. And this, I would expect you can all find the antiderivative. There's no more multiplication. There's no more division. Yeah, that'd be a good idea. All the cool kids. All the hipsters are doing it.
Oh,
it's all the way like this. Yeah. Okay, quick show of hands. How many of you guys feeling pretty good? You think you got this one? Axel's got it, Paul's got it, Garrison's got it, Jackie's got it, Karina's got it, Destiny's got it. Michelle, what do you got?
I got 1/2 so that's e to the power of 2x
1/2 e to the power of 2x. I love it. Keep it coming.
plus 2x
Plus 2x. Keep it coming.
plus negative 1/2
Okay, you said plus negative 1/2, but we're all friends here. I'm just going to write minus 1/2.
e to the negative power of 2x.
Oh my God, I love it. Almost.
Plus Charlie.
Plus Charlie. Don't forget about Charlie. Honest hands. How many of you guys have this? 1/2 e to the 2x plus 2x minus 1/2 e to the negative 2x plus Charlie. We get it? We're making progress. What I'm expecting is going to happen in some of the problems tonight when you look at stuff like this, you're not going to know how to start. But if you make the right series of moves, you're going to reach a point and be like, oh, now I know what to do. It's the algebra in the beginning that is going to trip you up big time. So let's just keep pushing. All right, number 4. X times the square root of x plus the 5th root of x squared. Need to find the antiderivative of that with respect to x. See what you can do. Remember that multiplication and division in the integrand are usually bad news. Bad news. But that's a square root, that's not. Oh my gosh, it's like you should look ahead into the unit guide about 4 days from now. There are actually people in the real world that do this. Number 1, I live in the real world, so that counts. Seeing some good starts here. Ah, that is a good start, son. Okay. I've seen a healthy number of folks that have rewritten the problem as x times x to the half plus x to the 2/5. Looking good. That's good. But if you have multiplication or division in the integrand, it's bad news. I think we still have multiplication going on in this x times x to the half. If only there was a way to write this without using multiplication, we could do something. X times x to the half. Diego, what do you see? No. X times x to the half. Those bases are the same. What do you got, Flora? Add the exponents so you get x to the what power? Right, part of it is you've got that exponent that you don't normally write. You don't write the 1.
3/2.
This is x to the 3/2 plus x to the 2/5. And unfortunately, I just erased it, but you know what this is? Power rule. You've got x raised to a power. This guy over here, power rule. Well, how does the power rule work? What are we supposed to do? The indefinite integral of x to the 3/2, what was that rule again? We do something with the exponent. What happens with the exponent? Add 1. So see if you can do this in your head so it's not quite as ugly. 3/2 plus 1 is 5/2. Then it's 1/5/2. Add 1 to the power, divide by the new power. Write 1/5/2 if you need to, but most of you should know that 1 divided by 5/2 is? Oh, so sad. 1 divided by 5/2 is 2/5. Well, keep it, change it, flip it action. Plus, do it again, x to the 2/5. Add 1. Oh no. 2/5 plus 1. 2/5 plus 1 is the same as 2/5 plus 5/5,
7/5.
which is 7/5. 1 divided by 7/5 is 5/7. Plus Charlie. Okay, I know I did not pick up the homework from last night. I wanted us to get more practice time. It's going to be okay. Assignment number 888 is due tomorrow. The test corrections and the reflection are due tomorrow. You got to get it both done. I'll be available during lunch. Melissa, it's going to be okay.